Why do I say that this is not a triangle? After all, it looks like one. Well, I'm going to show you that whatever this is, it is impossible for it to be a triangle. There are a few ways in which you can do this. There's a physical way that I suggest you might want to try. That is to get yourself a piece of paper, a pen, a ruler and a protractor and see if you can draw a triangle with the values of these edges and this angle. You will very quickly realize that it is impossible to construct a triangle using these values. What we're going to do though is use the sine rule, manipulating the formulas to show why one of these values must be wrong and what you'd need to do to correct one of the values in order to make this a genuine triangle. Now the first thing I'm going to try to do is figure out some of the other angles in the triangle. So let's bring up the sine rule to help us do that. And hopefully you remember that in the sine rule, the capital letter represents an angle and the same letter that's in lowercase represents the length of the edge opposite that angle. An easy way for us to start will be trying to determine the top angle. So I'm going to label the top angle x and I'm going to plug all of these values into the equation for the sine rule. We'll only need to use two of the formulas in the equation and I'm going to use sine A and sine B. So for capital A, which is an angle, I'm going to assign that the top angle, which is x, opposite x is 7, so that's going to be the opposite edge value, which is A, so A equals 7. Then the other angle is 70 degrees, so let's make B 70 degrees. And little b must be the length of the edge that's opposite the angle B. Well, you can see that that's 4, so little b equals 4. And now we can write the equation with the relevant values. So sine of A, well, we've got that A equals our unknown value x, divided by small a, which is the length of the opposite side, which is 7, must be equal to sine B. Well, B is 70 degrees, and all of that is divided by little b, which equals 4. Now if we want the value of x, we would need to get the sine of x and use inverse sine on that value. But in order to get the sine of x, we multiply both sides by 7. The 7's cancel on the left hand side, and we get that sine x equals 7 times sine of 70 divided by 4. Now if you run those numbers through your calculator, you'll get that sine of x is this extremely long decimal, 1.644, etc. But that's no issue, because if we want the angle x, what we have to do is take the inverse sine or arc sine of this number. I'm going to use an online scientific calculator so you can actually see me perform this action. Now I've already worked out the sine of x. You can see up here 1.644, and so if we take the arc sine of this value, it should return the value of the angle x. So inverse sine, which is arc sine, put the answer in and hit equals, and we get an error. So even though we have a value for the sine of x, for some reason we can't use it to get the value of the angle x. And we can see why this is so by examining a graph that shows all of the possible values for the sine of x. This graph shows all the values of sine and cosine. The x-axis shows all possible angles, and the y-axis shows the values for the sine of those angles. So for example, sine of 90 equals 1, sine of 45 is somewhere between 1 and half, sine of 180 is 0, sine of 270 degrees is minus 1. Now looking back at what we had, sine of the angle is 1.6. In fact, it's greater than 1.6, but the graph shows there is no angular value such that sine of the angle is around 1.6, because the maximum value for sine of an angle is 1, and the minimum value for the sine of an angle is minus 1, and 1.6 is outside of that range. So what can we do to make this into a genuine triangle? Well, there are a few options. We could shorten the base, or we could extend the left edge of the triangle, or we can change the angle so that when we run this calculation, sine of x will be between 1 and minus 1. I'm going to write this equation on the other side in a way that makes it easier for us to work with it. Now 7 times sine 70 over 4 actually can be written as 7 over 4 times sine of 70. It's just emphasizing the same value in a slightly different way. Now I said we're going to be changing the angle, and that means that we need to pick a suitable angle such that 7 over 4 multiplied by sine of the angle is no greater than 1. I'm going to ignore negative values of sine x so that our task is simpler. So how do we find this angle? Well, the angle isn't important at the moment. All we need to be thinking about is multiplying 7 over 4 by some number so that the overall result is 1 or less. So sine of the angle must be that number. And I'm going to make this really easy by reminding you that if you multiply 7 over 4 by its reciprocal, which is 4 over 7, that equals 1. So if we make sine of the angle 4/7, then 7/4 times sine of the angle will give us 1, which is an acceptable sine value. So if we're saying that sine of the angle is 4/7, we can get the angle by doing arcsine of 4/7. I'm going to remove the 70-degree angle because that doesn't work for us. And using a calculator to work out arcsine of 4/7, we get the value of another long decimal, which is 34.84, etc. Now if we plug this angle into the equation, sine of x will not be greater than 1. I'm going to round the angle down to 34, so that it's just an approximate value for arcsine of 4/7. So now we can rewrite the angle as 34 degrees. And because we rounded the angle down, when we compute the equation, sine of x is actually going to be a little less than 1. And if you run this side of the equation through your calculator, you will get that sine of x equals this long decimal. Because the sine of x exists, angle x must exist, and that would mean that the triangle does exist. We can check this in an online triangle maker, where we can set up the original scenario and then check the solution. So here's the original setup. The length of the base is 7, the length of the left edge is 4, and the angle on the right side of the base is 70 degrees. And no matter what I do with the left edge, we cannot create a triangle. So let's see what happens when we change the angle to 34 degrees. Now if we move the left edge, you can see that the end of the left edge crosses the right edge, and so a triangle is possible. So that's it. That's how you can use the sine rule to assess the structure of a triangle to see if it's real or not.